Welcome to your lesson on the unit circle. Big topic in trigonometry. Let's get going. Please take some notes. Let's begin here. The equation of a circle. The equation of any circle is given in this form. X squared plus y squared equals r squared, where r is the radius. Here's a circle. Center is at 0, 0. Therefore, our equation will be x squared plus y squared equals 16, because the radius here had a length of 4. 4 squared is 16. Simple equation. When the center of the circle moves, we also have to adjust the center. Based on what we know about translations, check it out. Here's what it looks like. This center moved from 0, 0. It went -2 on the x and up to here. So -2 on the x, remember we showed as +2. So x moved 2 in left, therefore we put +2, and y moved 2 up, therefore we put -2. Notice normally y would show the direction we travel, but in this case we do the same thing to it as we did to x, because it's squared. So it moved up 2, but we put -2 here. Equals 9 because the radius was 3. So 3 squared is 9. Okay, that's how we write the equation of a circle. Let's take a look at now, there's the general form then. X minus h squared plus y minus k squared equals r squared. H and k being the center of your circle. Alright, let's talk about the unit circle. The unit circle is a circle that has a center at 0, 0, like here, and a radius of 1. Notice here it's 1 in every direction. Here's the unit circle as well. Center here, 0, 0, and radius here we can see is 1. Okay, what is the equation of a unit circle? So using the equation of a circle we just saw, the formula, this is again, h and k is our center, but the center is 0, 0, so those will both be 0. So we have x squared plus y squared equals 1, because the radius is 1. That's why it's called the unit circle, because the radius is 1 unit long. So there is the equation of a unit circle. Moving on from there, angles in a unit circle. So let's say we're drawing an angle. Here's one leg. We're going to call this the initial side. We spin the angle this direction, and then we have what's called a terminal side. We've created an angle. That angle can sit in our coordinate plane with center 0, 0. So if we have a unit circle, that angle can also sit in the middle of the unit circle. So that is called an angle in standard position. Here's another angle in standard position. Notice we spun the angle this way. Okay, so in standard position, we're always spinning in that direction for positive angles. Here's our initial side, here's our terminal side. We've spun the angle and its vertex is at 0, 0. Okay, angles in standard position in the unit circle are measured starting on the positive x-axis and turning anti-clockwise, or means counterclockwise. So we can see we begin here on the x-axis and we spin the angle this way. That's an angle in standard position. If we are going negative angle, so this could be like positive 120 for example, if we went negative 100, we would go in this direction. So this direction for positive angles, this direction for negative angles. But they always begin at the x-axis here. Okay, this is kind of a key to what we're going to do with trigonometry, so make sure you understand these angles placed at the center of a circle like this, which is at 0, 0. Okay, positive direction, negative direction. Let's go on. So here we have a unit circle. Center is here. Here's 1 unit, one unit long right here. When we have a unit circle like that, let's say we said, I want to find out the coordinates of this point right here on the circle. I have this one point. I want to find out the coordinates. What are the x and y values right there? Let's take a look. So we can draw like that from the center connecting to there. We've created that angle we were just talking about. We can also draw a line going straight down, creating a right triangle here. We can call that the angle here, our angle in standard position, and we have this right triangle. So to find the length of x here, that will be the x coordinate, and here's the y coordinate. To find x and y, we can use basic trigonometry. We know, since this is a unit circle, that this hypotenuse has a length of 1. So now let's use basic trig. Sine of angle theta equals opposite of a hypotenuse. Sine of theta equals y over 1. Notice, since this is 1, because we're in a unit circle, we can now say y equals sine theta. So to get our y value, the length here, which is also the coordinate, the y value of this coordinate, we can just do the sine of this angle. That only works because this is 1 unit long. If this was a number different than 1, we would need to multiply sine by that number. Alright, to find the x value, we can do cosine. Cosine is adjacent over hypotenuse. So we do cosine of that adjacent over hypotenuse, we get this. Again, hypotenuse is 1. Therefore, cosine is equal to x. The x value is equal to cosine. So if we want to know this length here, we can just do cosine of this angle. And that gives us the x coordinate of this point. This is the heart of our trigonometry, so make sure you understand what's happening here. If we want that coordinate right here on the unit circle, we can find it simply by taking the cosine of this angle and the sine of that angle. Those will give us our x value and our y value. So for example, if theta was 59 degrees, that angle is 59, we could find this coordinate by doing cosine of 59, sine 59, and then we would have this exact location on this circle. In this case, it works out to 0.52 and 0.86. And when you look at the diagram, that makes sense. The x value is about 0.52, the y value is about 0.86. Great. We can also confirm that by using the equation of our unit circle, which we know is x squared plus y squared equals 1. We can put in those two values, 0.52 squared plus 0.86 squared, and if you did that, you would notice they equal 1. So everything makes sense so far. This is the key part of trigonometry. Let's look at something online to kind of take a look at that same idea. So here I have a unit circle and I'm spinning this angle. So I'm going to pause there. Notice the angle is given here in degrees. So when I have a small angle, tiny angle, look at the x value in blue. It's a big x value, nearly 1, because a small angle makes that triangle side go almost to all the length of the radius. Whereas the y value is tiny in green, tiny y value. But as I expand the angle of that triangle, notice my y value in green is getting bigger and my x value is getting shorter. And then eventually the y value will be 1 when I get to the top here, right? Because it's going to be almost the length of the radius. So that's the relationship between the sine and cosine and the point on the circle. Okay, let's go back to here. That's the key idea right there. When you need a coordinate on a unit circle, we take this cosine to find the x value and we take the sine to find the y value. Just get those key concepts ingrained in our memories, because this is the heart of trigonometry right here. We have a unit circle. That means the radius is 1 unit long. We can create these triangles or angles within the unit circle. To get a coordinate there, the coordinates of that point, we need x and y values. The x values are equal to cosine of that angle, and the y value is equal to sine of that angle. So to get the coordinates, we just do cosine theta, sine theta. All right, make sure you remember that sine is always for y, cosine is always for the x value. Okay. Now, what about tangent? I see sine and cosine. What about tangent? Try to find tangent in this circle here. What would you get? Well, tangent of that angle is opposite over adjacent. So tangent of theta would be opposite side over adjacent side. And our opposite side is sine theta. That's our length of y. And our adjacent side is cosine theta. That's our length of x. So tangent can be written like this. That's important to remember. Next, we know the equation of the unit circle is x squared plus y squared equals 1. Therefore, since we know the x value is cosine theta and the y value is sine theta, we can replace the x and y with those two, with cosine theta and sine theta. This can be rewritten. The order here doesn't matter. Sine can be first, cosine second. And also, another thing to notice is when we have cosine squared or sine squared, we can write it like this. This means the same thing as sine squared theta means the same thing as sine theta squared, like this. So that is what is called the Pythagorean identity, because it comes from, we can see from the Pythagorean theorem. That is also important to remember. So remember this, remember these parts here. This is a key slide that summarizes some key things about trigonometry. Okay, let's look at a few more things. There are 4 quadrants when we're graphing. First quadrant, second, third, fourth. In our unit circle, these can be represented by angles here. First quadrant will be from 0 to 90 degrees, and then 90 to 180 will be our second quadrant, and so on and so on. Let's get some really good focus on the next little bit here, because all the pieces will come together now. So here's an example. We're going to have a unit circle with an angle in it. Okay, so here's our unit circle. Here's an angle in standard position, and the angle is 45 degrees. So we've drawn an angle. We can always drop a line to the x-axis, which is what we always do there to create a right triangle. Now we want to find the coordinates of this point. We know from the rule we just learned that the x value is can be found using cosine of the angle. So cosine 45 will give us this length, and sine 45 can give us the y value, this length here. So do those on your calculator. What do you get? Hopefully you got 0.707 and 0.707, the same value for x and y. So that coordinate is at this location here. And that makes sense because this is an isosceles triangle. We know that that side and that side now, that's what this calculation tells us, that this must be 0.7 long and this is 0.7 long as well. And they're the same because it's an isosceles triangle. So now we know those lengths. We know this coordinate as a result. Next question. What angle will create the same triangle in the second quadrant? So this triangle sits in the first quadrant. Imagine you had to continue this angle until you create this triangle in the second quadrant. What will be the angle that gives you that one? Let's take a look. Let's check your work. So we have, to create the same triangle, we have to make actually a mirror image of it. So here is this triangle reflected over this axis, and here it is. So that angle is here 45 because we're creating the same angle. Sorry, same triangle. But the question is what angle here, starting from here, because we're doing a standard position angle, starting from this x-axis here, spinning there, what angle is this? Well, that angle must be 135, because if we have 45 here, we have to do 180, which would be all the way here, minus 45 to get here. Or alternatively, you can think, okay, I'm going to spin 90 degrees to here, and 45 additional degrees, which gives me 135. So the answer to that question is an angle of 135 will produce the same triangle in the second quadrant. Now, since that triangle is the same, the side lengths should be the same length, right? Well, let's check. Now we know that that coordinate will have coordinates x value of cosine of 135 and y value sine of 135. Remember, x is always from cos and y is always from sine, and now we have an angle of 135. So punch those on your calculator. Let's see what you get. Okay, you should have gotten these coordinates, and the numbers are the same, 0.707, but however, notice there's a negative here. Cosine of 135 produced a negative value, whereas sine of 135 produced the same as this one. Why negative? Because this x value here, that must be negative. Here's the positive x values, here's the negative x values on this side, so we go negative 0.77, but the y value, you're still going up on the y-axis, so still positive there. So everything makes sense. What we got here makes sense in terms of our triangle. Now, let's consider that. So that looked at in a different way. What if we said this, instead of using 135, we said I want to use 45? Well, that first one here is negative cosine of 45, because cosine of 45 produces this value, and we want the negative of that. We want negative 0.77. So that is equal to negative cosine of 45. However, sine, we can use sine 135 or 45. They both produce 0.707. We can see it here. So sine 135 and 45 are the same, and that's important to know. You'll see how that comes together in a minute. Okay, let's try another one. Here's another unit circle. We have an angle in standard position in blue, and an angle of 50 degrees have been spun here. So the question this time is, okay, so what's that coordinate? We know that coordinate is cosine 53 sine 53. So find that. What are the values? The values should be 0.6 and 0.8. So that tells us our x value is 0.6, that distance, and our y value, this distance, is 0.8. So there we have that. Now, what angle will create the same triangle in the third quadrant? So now imagine spinning all the way to the third quadrant and trying to put that triangle in here. It's going to be flipped around and stuff, but try to do it now. What angle from the beginning will get you to that place? Let's take a look. Here's our circle. Here's that triangle. We're trying to recreate this triangle in that quadrant, so it's upside down now and flipped. That angle is 53. Therefore, what is this angle? Okay, that angle is 233. 180 plus an additional 53 makes 233. So now we know that angle, so we know the coordinate of this point must be cosine of that angle and sine of that angle. So what is that? Okay, you've checked on your calculator, negative 0.6 and negative 0.8. Makes sense. It's connected to this one. Same points, both negative, because now we have a negative x value and a negative y value. So that should be negative and that should be negative. So it's like a mirror image of that point. Everything makes sense. Our sine and cosine produce the correct values, including the correct signs. But we can also rewrite that one as negative of both of the original ones. So we know that these are equal and these are equal. The negative of this is equal to that and that. So all these connections, important things. Make sure you've studied this carefully so far. There's a second video that's going to follow this one now, and we're going to get into much more detail with the unit circle. This was just your introduction. Hopefully everything makes sense so far. See you soon in the next video.